Yeah. So first, today everything is on this website, Shadertoy, and we'll do some live programming. So if you want to follow, open this website, shadertoy.com, and here's this new button which will create a new shader, and then we can do some shader programming. So if you are familiar with uh, game engines like Unity, then probably you heard about shader before, and you can write some custom shaders for materials, and then you can have some surface just don't look like standard Unity material, but something customized. And you can also have shaders for post effects. You can also have shaders for like compute shaders, just do some complicated computations like physics. All of those stuff can be done in shaders. And in Shadertoy, this is just a website where you can write some simple shader program and to see the result. Usually the shooters are not directly useful for video games because Shadertoy have a lot of constraints, but they are fun to make, and some of them show really advanced techniques like this one. Just can you imagine this whole person is not 3D model, but is entirely written in code. It's quite some insane stuff people are doing here. And but since we only have about 30 minutes, I want to finish that. I will not do any complicated stuff. Instead, we will do something really simple and completely useless, but looks pretty. It's called Julia set. The idea of a Julia set is that you have a complex number z, and for each iteration, what you will do is do z is equal to z squared plus c for each iteration. Or if you want to like make more messy, then you can explicitly say the n plus 1 iteration of the is the square of the previous iteration of the plus some constant number. And then since complex number are two-dimensional, then it's natural to just say complex number represents a point on this image. Then we will have two results. One is this complex number is small enough so it's converged. And another result is that this complex number is too large, so when we do this, it's just diverged into like infinity. And with those two, we can have just have an image like this. And here is the pseudocode. Basic idea is that we just do some calculation. When our z is too large, we say it's diverge, and then we will just return. Otherwise, we continue to this iteration until we diverge, or until we have enough iteration. Then we say our complex number is small enough, so it's converged. And with this, we can have like black, white colors of Julia set, and then we can also paint some later, just paint some additional color to it if we want. But now let's first start. Since since this language GLSL does not support complex number, we can of course just write complex number entirely as two separate floating point numbers, but then it's very easy to misuse them. So what I will do is I will create a complex structure. And complex structure is initially is like internally stored as a two-dimensional vector, even though it's really not a vector. There's a chat. How many lines is that? Wow. Oh, do you mean that? It's not that many. You mean the it's like 10,000 here. And then 600 here. So I can see about, sorry, not 10,000, it's just 1,000. And so about 2,000 lines we can have this. Of course, this code is really dense, and you can see it's just like insane, unreadable code. So is anyone following me doing this?
Yeah, I am.
Okay, so interrupt me if I'm too fast. So for complex number, we can have complex addition . Sorry, this is C++ syntax. In the GLSL, it's like this. Float syntax error, what? So because we need a semicolon. Oh, I need to return complex, not float. That looks good. So maybe I will just call it complex plus. And this function will just plus two complex number and get a new complex number. And we can have another complex. What we need to use in here, we need to square this complex number and add another one so we can have addition. But also just a square. For square, so we need C dot delta x. I have, oh, I see. Yeah, So for square, we basically just a complex number, and complex number is something like this, x plus iy. And when we square them, we get x times, sorry, square shouldn't get this number. I'm wrong. When we square them, it's x times x minus y times y plus I xy plus 2I xy. So it shouldn't be look like this. It should be like this. Okay, so Jess, are you still following me?
Yeah, so it's a vec2 of the distance and then 2 times x times y. Okay.
Yeah, just this is a mass of complex numbers, basically. I just wraps the complex number into vec2, even though those two functions are really obnoxious to write, but afterwards, when we use them, it will be much easier. And if we see UV as our just the position on the screen, but UV is from 0 to 1, so we can change them later. Let's just say our the initial complex number is UV. Later we need to scale them differently. Now I just want to show something. And then what we will do is we will run that loop, so we can see like we can run 100 iterations. And the new z is equal to complex square z plus some c. But we cannot do this plus because c is also a complex number, so we need to do this. So what is c? C is just a constant complex number that we choose. And we can choose anything. So I will just choose some number used by the Wikipedia. They use this like negative 0.51 something and 0.52 something, which is some good number to generate just pretty image. And afterwards, we can also have a radius, and we can see if we escape that radius, then we diverge, and we can just have something like 100. For the radius, because we are using the complex number to represent the point on the surface, so z dot data is just exactly the point on this surface, and we can use dot product on that, we should kind of get the double distance to the center, and we can see this. This means we are going diverge. We already diverge in this iteration, so we can just create. And afterwards, we can see this. This is the same, but if diverges, then the color is just maybe diverges is blue, else is white. Okay, looks like great. Look, something like this. With that few lines of code. Are you still following me, Jess?
Yep. I'm doing good.
Good. Okay. So we can see like that when it's diverged, we have blue, otherwise we have white. But the center is at here, which is not what we want. So we need to rescale the screen. And because UV is from 0 to 1, we probably want to from -1 to 1. So we can do this. UV. This will get us from This will get us from UV -1 in GLSL. When we -1 to a vector, we just -1 to each dimension of the vector. And this will give us from -0.5 to 0.5. And then times 2, we get -1 to 1. No, oops, it's not what I want. What I'm doing wrong here? Oh, it should be like this. Yeah. So now this looks better. This looks more like this, even though our scene is distorted with our screen resolution, which may or may not be what you want. If you don't want that, it's not like that, then you need to readjust. Yeah, we can do that if use Y here if we don't want this distortion. So, but I think this way is fine. So, but then the next step is to add some color to this, because blue is very boring. So what we can do is, if our scene diverge really quickly, we still can see when it's diverged. So we can lift int I here. Then if it diverges, then instead of showing pure blue, we can show some kind, depend on the which iteration we start to diverge, we can have some different color. What is this? Syntax error. Can't cast like that. Okay, it's I don't like this scale though, so let's see what this looks like now. No, what I did before. I did one of this thing before. Let me just check what I did before. Okay, power of 2. Get rid of this exp. Oh no, this looks a lot better. But probably if you makes the center looks darker, makes the iteration smaller. No, that's too small. It's still too small. 100 is the thing. Why this doesn't look as pretty as what I did before, but I guess I fine-tuned in this one because I had more time. I kind of fine-tuned some numbers so it looks a bit more prettier than this one, but the idea is the same. And then we can also add some animations. Just change this C ever slightly based on the time. So And we have some animation, even though this is probably still too large, so it looks weird. Now, so that's all about Julia set and Shadertoy stuff.